And what comes next? 2014 to 2017, Docker Swarm, Apache Mesos, Kubernetes, Nomad, all competing. By 2020 the race was over. Kubernetes captured 90% plus market share. Every major cloud provider offers managed Kubernetes, EKS, AKS, GKE. How did a Google-born project achieve total industry dominance? The answer is not just technology, it is strategy, ecosystem, and timing. You describe the desired state, Kubernetes figures out the rest. I want 3 replicas of this container, exposed on port 443. The control plane continuously reconciles actual state desired state. Self-healing, crashed pods are automatically restarted. This model is intuitive, auditable, and version controllable. Competitors used imperative models, do this, then that, which broke on failure. Declarative versus imperative. The Kubernetes control loop. Kubernetes defined the CRD, custom resource definition, extension model. Anyone can extend Kubernetes with new resource types without forking the project. This created an explosion of ecosystem tools. Istio/Linkered Service Mesh. Argo CD/Flux GitOps Continuous Delivery. Kata Event-Driven Autoscaling. Crossplane Infrastructure as Kubernetes Resources. Prometheus plus Grafana Monitoring Stack. The ecosystem made Kubernetes more valuable than any alternative could match. Google donated Kubernetes to the Cloud Native Computing Foundation, CNCF, in 2015. This was a masterstroke, no single vendor owned it. AWS, Azure, Google Cloud all invested in managed offerings. Competing with Kubernetes meant competing with the entire industry. Docker Swarm was tied to Docker Inc., a single company. Mesos was powerful but complex and lacked broad vendor commitment. Kubernetes became the safe bet, no CTO gets fired for choosing it. Platform strength, why it lost. Docker Swarm simplicity, 5-minute setup too simple for production, single vendor. Apache Mesos scale, ran Twitter, Apple too complex, steep learning curve. HashiCorp Nomad flexibility, any workload small ecosystem, late to market. AWS ECS deep AWS integration vendor lock-in, no portability. Cloud Foundry developer experience opinionated, limited flexibility. Complexity, the learning curve is brutal. YAML sprawl, networking, RBAC, storage. Developer experience, developers want to deploy code, not manage manifests. Cost, managed Kubernetes is expensive, many teams over-provision by 60 to 80%. Security surface area, misconfigured clusters are a top attack vector. Day 2 operations, upgrades, backup, disaster recovery remain painful. The joke persists, Kubernetes, turning a 5-line Docker file into 500 lines of YAML. The Kubernetes complexity tax. WebAssembly, WASM, on the server, start in less than 1 millisecond, sandbox secure, polyglot, could replace containers for some workloads. Platform engineering plus internal developer platforms, abstract Kubernetes behind golden paths, Backstage, Humanitech, Cratix. Serverless containers, AWS Fargate, Azure Container Apps, Google Cloud Run Kubernetes power without managing clusters. None of these kill Kubernetes, they build on top of it or offer alternatives for simpler use cases. Kubernetes becomes the infrastructure layer you never touch directly. Decision tree, do you need Kubernetes? Kubernetes is the Linux of the cloud. Common industry observation: the best infrastructure is the one your team never has to think about. Platform engineering philosophy. Kubernetes won through declarative APIs, an extensible ecosystem, and vendor-neutral governance. The CRD model created network effects no competitor could replicate. Complexity remains the biggest challenge, platform engineering is the answer. Kubernetes is not going away, but how we interact with it is changing. For most teams, use managed Kubernetes plus a platform layer, or consider serverless containers. The question is no longer should we use Kubernetes, but how much Kubernetes should we see?